Welcome back, listeners, to another exciting episode of JVM Internals Crashcasts. I'm your host, Sheila, and today we're diving deep into the fascinating world of Classloader hierarchies. We're currently in Level 2 of our series, focusing on operational understanding of the JVM. This episode is part of our Class Loading in Depth chapter, where we'll unravel the mysteries of how Java classes are loaded into memory. Before we begin, let's quickly recap. We've just finished discussing JIT compilation in our previous episode. Now we're moving on to explore how classes are actually loaded into the JVM. Victor, are you ready to unload some knowledge about class loaders?
Absolutely, Sheila. I'm excited to demystify the class loader hierarchy for our listeners. It's a crucial component of the JVM that often goes unnoticed but plays a significant role in how Java applications work.
Great. Before we dive in, I have a quiz question for our listeners to ponder throughout the episode. Here it is. In a typical Java application, how many different types of class loaders are involved in loading classes, and what's special about their relationship? Victor, any thoughts on this question without giving away the answer?
That's an intriguing question, Sheila. It really gets to the heart of what makes the class loader hierarchy unique. I think our listeners will find the answer quite surprising, especially when they learn about the special relationship between these class loaders. It's not as straightforward as one might initially assume.
Excellent. Let's start with the basics. Victor, could you explain what a class loader is and why we need a hierarchy of them?
Certainly. A class loader is a part of the Java Runtime Environment, or JRE, responsible for loading Java classes and interfaces into the Java virtual machine. As for why we need a hierarchy, it's all about organization, security, and flexibility. Imagine a library with multiple floors and sections. That's our class loader hierarchy. Each floor or class loader has its specific purpose and set of books, or classes, it's responsible for.
That's a great analogy. So, if I understand correctly, different class loaders are responsible for loading different types of classes. Could you break down the main types of class loaders for us?
Absolutely. There are three main types of class loaders in the standard hierarchy. First, we have the Bootstrap class loader. This is the root of the class loader hierarchy. It loads core Java classes from the rt.jar file. Think of it as the restricted section of our library, containing the most fundamental and trusted books. Second, there's the extension class loader. This loads classes from the X directory of the JRE. It's like a special collections section in our library, containing additional, officially sanctioned books. And third, we have the application class loader. Also known as the system class loader, this loads classes from the application's class path. It's akin to the general circulation section of our library, where most of the books or classes your application uses reside.
That's really helpful, Victor. Now, I've heard about something called the delegation model in relation to class loaders. Could you explain what that is and how it works?
Of course, the delegation model is a key principle in how class loaders work together. When a class loader is asked to load a class, it doesn't immediately try to load it itself. Instead, it first delegates the request to its parent class loader. This continues up the chain until it reaches the Bootstrap class loader. If the parent can't find the class, then the child class loader attempts to load it. To use our library analogy, it's as if when you request a book, the librarian first checks with their supervisor, who checks with their manager, all the way up to the head librarian. Only if none of them have the book does your original librarian look for it in their own section.
That's fascinating. It seems like this could have some interesting implications. What are some of the benefits and potential pitfalls of this delegation model?
Great question, Sheila. The main benefit is security. By delegating upwards first, we ensure that standard Java classes are always loaded by the Bootstrap class loader, preventing malicious code from replacing these critical classes. It also helps avoid loading the same class multiple times. However, this can sometimes lead to unexpected behavior. For example, if you have two versions of the same class in different parts of your class path, the one that gets loaded might not be the one you expect, due to the delegation model.
I see. That could definitely cause some head-scratching moments for developers. Now, you mentioned earlier about class loader namespaces. Could you elaborate on what those are and why they're important?
Certainly, each class loader has its own namespace, which is essentially a logical grouping of the classes it has loaded. This is crucial for maintaining separation and avoiding conflicts between classes with the same name but from different sources. For instance, let's say you have two different libraries that both contain a class named helper. Thanks to class loader namespaces, these can coexist in your application without conflict, as long as they're loaded by different class loaders.
That's really interesting. It reminds me of how in some programming languages we use namespaces to avoid naming conflicts. Now, I'm curious about real-world applications. Are there any frameworks or systems that make extensive use of custom class loaders?
Absolutely. A great example is the OSGi framework, which stands for Open Services Gateway Initiative. OSGi uses a sophisticated class loading model to create modular Java applications. Each module, or bundle in OSGi, has its own class loader, allowing for better isolation and dynamic loading or unloading of modules. Another example is application servers like Tomcat or JBoss. They use custom class loaders to isolate different web applications running on the same server, ensuring that classes from one application don't interfere with another.
That's fascinating. It really shows how powerful and flexible the class loader system can be. Now, as we're nearing the end of our episode, I think it's time to reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly. The answer to our quiz question is that in a typical Java application, there are three main types of class loaders involved: the Bootstrap class loader, the extension class loader, and the application class loader. What's special about their relationship is the parent-child hierarchy and the delegation model we discussed. Each class loader delegates to its parent before attempting to load a class itself, creating a chain of responsibility.
Thank you, Victor. To summarize the main points of our discussion today. 1. The class loader hierarchy consists of three main types: Bootstrap, extension, and application class loaders. 2. Class loaders follow a delegation model, always asking their parent to load a class before attempting it themselves. 3. Each class loader has its own namespace, allowing for isolation and avoiding naming conflicts. 4. The class loader hierarchy provides security, flexibility, and organization in how classes are loaded into the JVM. 5. Real-world applications like OSGi and application servers make extensive use of custom class loaders for modularity and isolation. In our next episode, we'll be diving into custom class loaders and how you can create your own. Until then, keep exploring the fascinating world of JVM internals. And to our listeners, if you've enjoyed this episode, please don't forget to subscribe to JVM Internals Crashcasts and leave us a rating. Your support helps us continue bringing you in-depth explorations of Java and JVM concepts. Thank you for listening, and see you in the next episode.